Hey guys, welcome back to a new video. In the last video we made this beautiful ShoppingDao class here, or interface actually, in which we implemented all of our functions we need to access our database. In this video we will test this interface, or actually our room database, so if these functions here actually do what they should do. And for that we now need to think about if these will be local unit tests, so tests that run on the JVM, or instrumented unit tests that require the Android emulator. So I give you a short amount of time here to think about that. You can pause the video, and now I'm going to give you the answer, and that is this must be an instrumented test, because creating a room database requires the context, and actually theoretically we could also make this a local unit test, because Sqlite could also be accessed locally. But in that case, if we want to test Sqlite databases locally, then it will take the version of Sqlite that is installed on your local machine and not the Sqlite version that is installed on your Android device. And we of course want to test if it is working on an Android device, so we should really make this an instrumented unit test here. For that, we will go inside of our Java package, then inside of our Android test source set here. And usually when we write unit tests, then we want to have the same package structure as in our normal package here. So you can see we have our data package, local, and in here is our ShoppingDao. And if we now want to write a test class for that ShoppingDao, that should be in the same package structure. So we go inside of our shopping list testing YouTube here, our root package basically of Android tests. We create a new package here called data.local. So exactly the same structure as we have here. And inside of that, we create a new content file class called ShoppingDao test. And this will be a class. And now we need to add some annotations on top of this test class here. On the one hand, we need to specify add run with, and in the parentheses we write Android JUnit for :class. So what the heck does that mean? So in general, JUnit, so the testing library, is a library that is used to test Java or Kotlin code, or any code that runs on the JVM basically. And here we are not inside of such a plain Java or Kotlin environment, because we are inside of an Android environment. And that is different as the JVM, because we run our tests on the Android emulator and not on the JVM, at least if we are inside of this Android test directory here. So those are instrumented unit tests, and they run on the Android emulator because they need Android components. And with this add run with annotation, we just make sure that all these tests inside of this class will run on the emulator, and actually also just to tell JUnit that these tests are instrumented tests in here. And then the next annotation we need to add here is, or we can add, that is actually optional here but recommended, that is add small test. So if you remember in the first or second video, I don't really remember, but there we had that testing pyramid in which we had three kinds of test cases. First of all, unit tests, which were the base, the foundation of the pyramid. Then we had integrated tests that just test different components, so how they interact with each other. And we had UI tests, which made up the top of the pyramid. And the unit tests of that pyramid, so the base, are actually the small tests here. So with that small test annotation, we just make sure, or we actually just tell JUnit that what we write here are unit tests. So if we would write an integrated test here, or integrated test in this class, then we would annotate this with add medium test. Or if we would write UI tests or end-to-end tests, however you want to call it, we would call that a large test. But this will be a small test. And the differences between those test cases you can actually see in this table here. You can pause the video and compare that. I won't go through that now because it's pretty self-explanatory, I think. Anyways, let's actually jump into the test class here and think about what do we need to test our room database. So we of course need our database, and we should create a reference to that here. So private lateinit var database, which is a shopping item database. And if you remember from the last video or second last, then we shouldn't initialize this right here. so globally, because we should write a function that sets that database up before every test case that we just annotate with the add before annotation, just to make sure that we have an entirely new database for each test case, because that should really be independent. And especially with databases, if we insert something into that database, then we don't want that this item is still in the database if we are inside of another test case, because that could highly manipulate that outcome of the test case basically. So we'll also have that private late init var for the DAO object, so DAO, which is a ShoppingDao. And then we will write that function I talked about, function setup, in which we just create that database now. And we annotate that function with add before. So that will just be executed before every test case inside of this class. And in here we use database is equal to room dot, and usually you use that database builder now, but we use this in-memory database builder. So the difference to the database builder is actually that this is not a real database. So, well, it is a database, but in memory means it will only hold the database in the RAM and not inside of the persistent storage. So what we save inside of this database won't actually be saved in a real sense of saving. It will only be saved for that test case. And of course, we don't want to set up a whole new database for each test case that just stays in persistent storage. So that is why we use that in-memory database builder here, and that will take the same parameters, the context, and you saw that in the last video how we can get that. We can use application provider dot get application context here to get a reference to the context inside of a test case. And the class of our database is shopping item database class.java. Then afterwards we write dot allow main thread queries. So that if we apply that function on that builder, it will actually do exactly what the name says. So we allow that we access this room database from the main thread. Well, usually if you use a room database or any database, you of course want to access and write to that database from a background thread, because that can be a blocking call to write or read from the database. But in test cases, we explicitly want that it runs on a single thread, because if we have multi-threading in test cases, that could mean that these different threads manipulate each other. So because we can predict how the threads run at the same time, this will be a little bit different for each test case. And in the end, as you know, we want complete independence for each test case. And that is why we execute this room database in the main thread, so that all actions are executed one after another. So after that, we can finally call .build to get that database, and we can also reference our DAO by writing database.shoppingDao. And then if we have a before function, we often also want an after function, so a function that is executed after every test case. And in this case, we simply want to close the database after each test case. So after function that is called teardown. And in here, we just call database.close. And let's actually take a look in our ShoppingDao, which functions we want to test here. That is our insert shopping item function, delete shopping item, observe all shopping items. Basically every function we have inside of that ShoppingDao we want to test. And let's start with this insert shopping item function. So we just test if we insert a shopping item in our database with this function, if that works as we expect. And you can also see that this is a suspend function, so we need to execute that from within a coroutine. Then if we go back to our ShoppingDao test, let's write the test case here, annotate it with add test, and call it function insert shopping item, which must be executed in a coroutine. And as I said, we don't want concurrency here in test cases, so basically multi-threading. And that is also why we will use run blocking for the coroutines here. So if you don't know run blocking, that is just a way to execute a coroutine in the main thread. So that will actually block the main thread with suspend calls, but we can execute suspend functions inside of that coroutine. And usually we would just write run blocking here. But as you can see, here is also a coroutine called run blocking test, which we will use because that is optimized for test cases basically. So what optimize actually means here, on the one hand, this run blocking test function will just skip the delay function. So if we have a function in which we delay a coroutine, this run blocking test will just skip over that, so it doesn't delay our actual test case. And also if we press Control Space here to see the functions we can execute, you can see there are a bunch of functions that we don't have in the run blocking function itself. So we have access to the current time of the coroutine, we can advance the time by, so we can basically modify the time of the coroutine, which is pretty cool here and pretty useful if you want to test a coroutine that needs this behavior, where you just want to change the current time and check if the coroutine does what it should do in that case. We could pause the whole dispatcher here, we can resume it and all that stuff. We don't need that here, but you should still get in the habit of writing your coroutines that you use in test cases in this run blocking test function here. So let's actually think about how we could test that insert shopping item function. Well, that is not that difficult. We just create a shopping item. We will insert that in our database here, and then we will simply read the items from our database and check if that item is contained there. So we will first of all create a shopping item here. Val shopping item is equal to new shopping item, and we can give that any name, that doesn't matter here. Any amount, let's say 1, any price, 1F, just any string for the image URL, and we want to give it an ID as well. Just use 1 here. And then we will use our DAO and insert that shopping item with our function. So that is the actual function that we test here, if that works as expected. And now, how can we read our entries actually from the database? So we don't have a function here in our DAO that just gets an item by its ID. That would be useful, but I also don't think it's a good idea to just create such a function for our test cases, because we don't need that in our actual app. But we have a function that observes all shopping items, and that will also retrieve a list of all shopping items, so we can just check if that item we inserted is contained in that list. So let's actually do that. We write val all shopping items is equal to DAO dot observe all shopping items. But now we have a problem, because that returns a live data and not the actual list. And live data, as you know, runs asynchronous, and we don't want that here in our test cases. And luckily, there is a super helpful class by Google that helps us with that problem. And I actually will just copy that that file here. That's not a class, that's just a plain Kotlin file with a function. I will just paste this inside of this project here. You can get this in the description from my GitHub repository. So I will explain what it does, but I don't see any reason in implementing it here on our own, because you can just reuse this class for every of your projects. Just copy and paste. And we will paste that actually in our root package here of the Android test directory. So that will be called live data util Android test. Press OK here, and you can see I'm talking about this function here. So as you can see, that is a function called get or await value, and that extends live data. So we can just call that function on live data objects, so on the function we have here. But let's actually try to understand that. We have a parameter time, which is equal to 2. So that basically specifies a timeout, which is set to 2 seconds in this case. So we also can specify the time unit here. And we have a function after observe. But actually for us here, we don't need to change any of these parameters. So we also don't need to provide parameters here. In the end, what this function does is it will wait until this live data we call this function on returns a value. So if this actually takes longer than 2 seconds by default, it will throw a timeout exception here. And that will never be the case here in our case, since we just get something from our room database. And in the end, we just want to get the value of a live data object. And that is what this function does here. So just make sure that you paste this file inside of your Android test directory. And then we can use that function in our ShoppingDao test on this observe all shopping items function here. So because that is an extension function, we can just call .get or await value. You can see we choose that function here without the lambda block. and we don't need to provide any parameters. And if we then click on all shopping items, press Q, Control and Q actually, then you can see that is a list of shopping items. So that is the list of shopping items that this observe function here returns. And after that, we can just work with that list now. And there are actually also other ways to test live data, which you might see something in the internet, but Google actually uses this function in all of their examples. So I think that is a pretty good practice here if Google uses that. So now that we have that list of all shopping items, we can write our assert function. So now we want to actually assert that this item we created here is contained in that list. So because we inserted that item, it must be contained if the test should pass. So we use assert that, and we need to import that from the truth library as we used in the previous videos. We want to assert that all shopping items dot contains our shopping item we created on top here. And you can also see that we get a warning here with that run blocking test. And if we press Alt plus Enter here, you can see we should add this add experimental coroutines API annotation to our class. Not to this function, we actually need that several times in this class. So we scroll up here to our class annotations and we add this annotation experimental coroutines API. And then you can see the warning goes away, probably because that is a pretty new function here. We just should add that annotation. And let's actually try to run that test case now by clicking on this little play symbol here and click on Run Insert Shopping Item. Then this will load and of course also launch our emulator here. There we go. So let's wait until our test case is actually run here on this device. Gradle is taking ages here. And now you can also see why you should always use local unit tests on the JVM if you can do that. So if you don't necessarily rely on Android components, you should always make that a local unit test. Let's take a look here and you can see our test failed. Surprise, surprise. This job has not completed yet. What the heck does that actually mean? Well, the problem here is actually our live data. Our live data makes us problems here because it is asynchronous by default, and even though we use run blocking test here, JUnit doesn't like that. And to solve that problem, we need to explicitly tell JUnit that we want to execute all of the code inside of this test class here, one after another, so one function after another, basically in the same thread. And we do that by specifying a so-called rule for a JUnit. And that will be a so-called instant task executor rule. So var instant task executor rule, this one here, and we set that to a new instant task executor rule here. That just doesn't take any parameters, but we need to tell JUnit that this is actually the rule for this class by writing at get:\rule. And if we now rerun that test case here, let's take a look and wait until Gradle is hopefully a little bit faster this time. You can see the test case is running and this time it succeeded. So that means our insert shopping item function works as expected. So let's actually test the next function, which is our delete function. Let's minimize that and write a function here at test function delete shopping item, and also set that equal to run blocking test. Here we will create the exact same item again, so we can just copy and paste that. So that is again a totally new database that we have here. Because of this before annotation, we just recreate the database in before each test function here. So that is really independent, and we can also reinsert an item with the same ID basically. And then we will use our DAO to insert the shopping item we just created, because if we don't have an item in our database, we of course can't delete one. And then right afterwards, we will delete that item again. So delete shopping item. And then we again get all shopping items by writing DAO.observe all shopping items .get or await value. So that will again contain the list of all of our shopping items, but this time this list should be empty because the only item we inserted here was deleted immediately afterwards. So this time we assert that all shopping items dot does not contain this shopping item we created above. So then we can run that and take a look if that hopefully succeeds. And as you can see, that succeeds. So our second test case is also working properly. And finally, we also want to test the function to observe the total price sum. We actually don't want to explicitly write a test case to test this observe all shopping items function, because we already implement that also in our other test cases here. So that actually must be working. And it's also pretty hard to actually test that. Anyways, let's actually test the other function here. So add test function observe total price sum, also equal to run blocking test. And now let's actually think about how we want to test that. Let's first of all insert that shopping item again. And let's actually insert this several times here. So let's duplicate that with Control D. Name this shopping item 1, shopping item 2, and shopping item 3. And now we write some different amounts and prices for these different items. So let's choose anything here that makes sense. 2 times the price 10. Then we have, let's say 4 times. Let's also use a float number here. For example, 5.5. And something with 0, for example, and a very high price. And now we want to insert those 3 items. So DAO.insert shopping item 1, 2, and 3. And this time we don't want to observe on all shopping items. Instead, we want to observe on the total price sum. So total price sum is equal to DAO.observe total price. And you can see that now returns a live data of type float, so actually the total price. So again, we can call dot get or wait value here. And what do we actually want to assert now? We want to assert that this total price sum dot is equal to, and now we can check our amounts and prices, so equal to 2 times 10F plus 4 times 5.5F. And the third item is irrelevant because the amount is 0, so the multiplication of 0 and 100 is also 0, of course. So the total price sum must actually be the same as this term here. And if we now scroll completely to the top, we can actually run all of our test cases just because that looks so satisfying. Run that and take a look what it will do. You can see, hopefully, that everything works. And oh, we get an error here. Okay, let's take a look here in our test case. Something must be wrong here. And I already see the error here. Maybe you've already seen this and thought, what the fuck is Philip doing here? But we actually inserted 3 items with the same ID. So it will actually replace each item every time we insert an item here. So we just need to give it a different ID each time here. And if we now rerun our test cases here, and then wait a little moment, hopefully it should work right now. And as you can see, it does. So that is actually the reward for writing test cases. You get those check marks here, which look super satisfying. I hope you enjoyed this video and learned something new. I know this were a lot of new concepts here in this video with this room testing stuff, instant test, executor rule, all those annotations here, run blocking tests, a lot of new stuff, but I think that everything should get clear to you. If not, then just put your questions in the comments and I can try to help you out with that. See you in the next video. Have a nice day. Bye bye.